Assalamu alaikum. I am Tahir Javed from Department of Computer Science, Allama Iqbal Open University. In this program, we will explore Unit number 8, Introduction to Databases, Data Warehousing and Data Mining of course Information and Communication Technologies. This course is offered at graduate level. In this program, we will discuss about databases, database management systems. Database management system is basically a software tool that helps us to manage, to create huge amount of data in a structured and efficient way. It acts as a bridge between the user and the database, allowing us to easily store, retrieve, update and delete data. These are commonly known as CRUD operations. CRUD operations are C for create, R for read, U for update and D for delete. Imagine you are running an online store. You need to keep track of customer orders, products and payments. A DBMS makes this possible without manually managing tons of files or spreadsheets. Some popular examples of DBMS software are MySQL, which is widely used for web applications, Oracle databases, which is known for its enterprise level performance, PostgreSQL SQL, which is a powerful and open source tool for database creation and management. In short, a DBMS simplifies data management and ensure data is consistent, secure and easily accessible. Now we will discuss about database, what it is. A database is a structured collection of data that is organized in a way that makes it easy to access, manage and update. This data is stored electronically in computer system and it can be anything from names and numbers to images, videos, records and so on. Think of a database as a digital filing cabinet. For example, student records in a school system, bank account and inventory data in a retail business. All this information is neatly organized so it can be searched, stored and modified with the help of a database management system. In short, database is the backbone of almost every software application that deals with data. As given in this figure, there are number of components of databases that can be data, tables, records, fields, queries, forms, reports. Now I tried to explain these components one by one. First one is field. Field is basically, it holds an individual piece of data. You can think of it as a column in a database. Each field stores one type of information. For example, names, addresses, phone numbers. These all are some of the fields, some of the types. Fields are usually named descriptively, so it's easy to understand what data they contain. For example, in a phone book, the fields might be name, addresses, email addresses, phone number, etc., etc. It's also important to note that fields can sometimes be empty and we call them null values. Fields are essential because they define the structure of your data, helping you to organize and retrieve the right information when needed. What a record is, it's one complete set of fields. It contains all the related data about a single item or person in a table. A table is also called an entity. Its record is represented as a row. For example, in a phone book, a single record might look like that Muhammad Ali, street number so and so, phone number this. This row includes all the fields, name, address and phone number for one person. Database can be unlimited records of different entities, of different tables. What tables are? Tables are basically the backbone of any database. Table is a complete collection of related records. You can think of it as a grid made up of rows or records. And columns. Columns are basically fields. Each table in a database stores data about one specific topic. As shown in figure, customer tables having records of all relevant customers. It contains fields, customer ID, its first name, its last name, its phone number and its country. A student table can have students, courses, teachers, records. A single database can have thousands of tables, each managing a different type of data, but all connected when needed. Tables keep your data organized, searchable and easy to manage, making them one of the most essential components of a database. Next, there are several types of databases. Some most important are centralized databases, relational databases, distributed databases, NoSQL databases, cloud databases, object-oriented databases, hierarchical databases, and network databases. So, I will discuss some most important types. These are hierarchical databases. Hierarchical databases organize data in a tree-like structure. When each record has a parent and child relationship, they are fast and efficient, especially for one-to-many relationships. For example, we are storing a structure of an organization that shows proper hierarchical. Next is network databases. These databases are like hierarchical databases but more flexible. In these, a child can have multiple parents, forming a graph structure instead of a tree. In tree don't contain any type of loops, but graphs can. So, example used in complex applications like telecommunication and airline reservation system. Another type is cloud databases. Cloud databases are hosted on cloud platforms. These are mostly distributed databases. These offering scalability, high availability, and pay-as-you-go pricing. For example, multiple businesses use Amazon RDS or Google Cloud databases to manage their data without maintaining physical servers. Another databases are graph databases. These databases are designed for data with complex relationships. They use nodes for entities and edges for relationship. For example, at social media platforms, we use friends, comments, and likes and can store in graph databases. Then relational databases. Most important, most used database types is relational databases. Tables are used in relational databases. They organize data in it and define relationship between them using keys like primary key, secondary key. For example, student table might link to a courses table through a common field like student ID. This model presents and connects these using this key. This also removes a redundancy. Let's explore the entity relationship diagram. Entity relationship diagram visually represents how different entities in a database are related to each other. At design time, we call them entities, and at later time, implementation time, we created tables from these entities. In this example, there are two entities. One is student and second is course. In student entity, there are three types of attributes. In latter, we create these fields or columns in the table. These are roll number, name and phone number. And in either case, in course table, these are course code, course name and department. There should be a primary key in each table. Primary key is basically an attribute that must be unique. In student table, it can be a roll number. In course table, that can be a course code. These two entities are connected by a relationship called is enrolled in. This showed that a student can enroll in one or more courses, and each course have multiple students. Relationship defines how entities interact with one another, while attributes provide details about each entity. Entity relationship diagrams are extremely useful. It told us that how data will connect in future. It's clearly understand the data structure and how everything connects. Let's now discuss data warehousing, a key concept in modern data management. A data warehouse is a centralized repository for the integrated data that should be a large data that can't be handled in normal databases. There are different sources that brought together, cleaned and stored in consistent format. It's designed specifically to support data analysis and decision making rather than everyday operation. This makes it a powerful tool for gaining insights over time. As the diagram shows, there are different layers. These are operational systems, integration layer, that's a data warehouse, and the data marts. From previous layers, data comes to data warehouse that manages all the relevant data for analysis and decision making purposes. In businesses, data warehouses are widely used for business intelligence that helps organization to generate reports, to analyze trends, and to make data-driven decisions. So, in short, data warehouse is where all the critical data comes together for strategic planning and analytics. There are 4 key features that define data warehouses. These are as shown in figure. These are subject or category oriented. In a data warehouse is built around specific subjects like sales, customers, products, finance. Rather than day-to-day operation, this helps focus on decision-making areas. The second one is integrated. These components, these simple databases should be connected as data comes from multiple sources like sales system, customer system, supply chain, and these are combined in a consistent format. This makes it easier to analyze across different departments. The third one is time variant. Data warehouse stores historical data. We can analyze trends over time. For example, at a specific season, a specific item sales that can be forecasted for coming season. The fourth one is non-volatile ability. Once data is stored, no one can change it randomly. This makes it stable and reliable for long-term analysis. These features make a data warehouse more powerful for business intelligence, for decision making, and for strategic planning. Think about a supermarket chain like Walmart. It collects data from thousands of stores, including sales, inventory, customer preferences, supplier details. All this data is sent to a central data warehouse where it analyzed and then to identify top selling products, to predict demand trends, to optimize inventory levels, and to launch targeted promotions. This kind of deep analysis helps the business make smarter decisions and stay competitive. So a data warehouse is like the brain behind smart business strategies. Our last topic is data mining. What data mining is? Data mining is the process of discovering patterns and trends from large previous data sets. It uses techniques from machine learning, statistics, and artificial intelligence. Some common uses are e-commerce, health diagnostic, credit scoring, supply chain optimization, detecting fraud transactions, predicting customer behavior, recommending products. Data mining is used in these sectors and many more. In e-commerce, we can use it for recommending products based on browsing and purchase history. In healthcare, we can use for predicting, analyzing, and curing diseases. In finance, we can use in multiple sites like fraud detection. We can use in logistics for demand forecasting, for optimized delivery routes, for shortest path, and it turns raw data into actionable insights. So in this program, we learned that database help us to store and manage structured data. Data warehouses integrate data from different sources for analysis, and data mining reveals useful patterns hidden in that data. Together, they empower organizations to make informed, data-driven decisions. Take very good care of yourself. Thank you. Allah Hafiz.